Hello everyone, welcome back. I'm back with a video on data science and machine learning common concepts. This will be the fifth video in the playlist called Data Science Levels. Let's see what all topics you should cover under DSML concepts. There are a lot of concepts which are in general very common concepts and does not belongs to any machine learning model as such or data science as such. It's a common concept. If you know them, the way you work, the way you think, things becomes easier to understand high concepts at the level. And these are very important concepts at the same time because many people do fail to answer them in the interviews. These are like a general knowledge within data science domain. So you must know them thoroughly without miss. Something like what's the difference between supervised, semi-supervised, unsupervised learning? Well, there are a lot more types of learnings, but to the minimum, one is expected to know this much. Um, like how is semi-supervised different from unsupervised, and what is a supervised learning? So make sure whenever you answer them with an example, real-time example, and that makes more sense. I have made already one video in the interview question set where you can see how you are supposed to answer this sort of questions. I have explained them. So you can go and explore it there. Let's see the next question. The next question will be very common like, do you understand bias variance trade-off? What does that mean in context of a ML model? How that can be corrected? What it means to me to for a model to have high variance? Okay, let's test your knowledge. So do you know any such model which has high variance and low bias? Can you relate, can you recall any such model? Okay, think about it. I'll give you a few more seconds. Do you know any model which has really high variance? And of course, whenever the variance is high, the bias goes low automatically. That's what the variance bias trade-off is all about. A, a general model, a best model is found between the bias variance trade-off, wherever you have neither too high variance nor too high bias. So that where you get a general model. So do you know any such model which has really high variance? Well, that's your decision trees. Decision trees are having really high variance. And what does it mean to have a high variance by a model? Do you, so I give you an example. Decision trees have really high variance, but what does that mean? What do you mean by high variance? What happens when a model has a high variance? Well, these are the fundamental intuition oriented questions that is difficult to understand, but if you know them, you can relate statistics and machine learning together. So knowing this answer to these questions are very important. And a lot of the time, these questions comes like same straightforward way how I have put on the screen by your interviewer to you. So do not get surprised if you get this sort of questions. A lot of the time interviewer want to understand your depth understanding of these concepts, and this sort of question can be thrown to you, so you should be good at catching them and answering them at the same time. Well, to answer this out, a model has high variance, that means a model is overfitted. So that's the reason decision trees are more prone to overfitting because of high variance. And how is that handled? So, well, that is tried to be handled by using random forest classifier or random forest in general. Okay, so random forest, if you remember, see my last video, I have asked the question there, why random forest is popular? What sort of problem that solves? Well, random forest solves high variance problem. Now, the question here can be how it does. So that's what you should read about the random forest to understand how it handles high variance without affecting the bias too much. Let's go and see the next part of it, which says a model has high bias, and what does it mean? And do you know any such model which can have high bias by default? So if you have ever heard of gradient boosting algorithm or XGBoost, these are the boosting algorithms, and by default they always have high bias, biases actually means low uh, underfitting basically, or low learning. So yeah, so the answer is XGBoost and gradient boosting algorithm. So see, you have the issue. So your random forest tries to handle the high variance or tries to overcome the overfitting, but that does not mean it will always come. Okay, most of the time, if your model is not trained well enough, good enough, then it can tend to be overfitted. At the same time, for gradient boosting algorithm, if it is not trained good enough or tuned good enough, then it can be underfitting. And that's why the best way to overcome both of this problem would be if you can combine random forest and the gradient boosting algorithm, then they can try to solve this problem of high variance and low variance and vice versa. So, and this method is called something. If you know, just comment it out. If you don't know, then think about it. What is that technique called where you combine multiple models? And there where your next question can be, which will just take in some time. So, what is a model overfitting and underfitting? Yeah, so the question can be this way also, very straightforward way. What is overfitting and underfitting? Or it can be indirectly way, like on the ever question, like what is high variance means, what does it means to have high variance, etc. So be open to receive all sort of questions, all different ways. But again, if you get confused and if you're not familiar with any word, don't feel hesitant, don't lose your confidence in the interview. Feel free to ask question back to the interviewer saying that I haven't heard, can you give me in some different way. Always keep asking questions. That shows your personality, about how curious you are, how do you put your views forward, what happens if we don't understand, because that's how in real time we interact with clients. Whenever, I mean, every time you can't be genius and understanding everything the other person has spoken to you. So there where you have to go ahead and say politely, "Look, I did not understand this, please tell me what do you mean by that." These are good attributes or good attitudes, rather, I would say, any interviewer expects a candidate to have in. Well, okay, let's go to the next question, that is, how can you handle overfitting, and also how can you handle underfitting? So let's say you identified somehow how the overfitting can the model is overfitted. Now the question is, how can you handle, what are the different ways that you should be very much clear about. By the way, here the question is, how do you identify if a model is overfitted or underfitted? That's again a good question. That can be again one of the interview questions. So by the way, everything put on this slide can be an interview question. So do not skip any one of them. Take all of them thoroughly. And coming to the answer to these questions, if you want, I can provide you. But again, these are open source questions and the answers will be flooded on internet too. So you can go and Google directly with these questions, you'll get the answer. But again, if whenever I'll be talking about these answers, I'll be always going to connect it back to the business. And if you want in that form, let me know, comment in the comment box. Okay, next question is, what is dimensionality reduction techniques? Okay, so what is that techniques? Do you know? Are you aware of what are the various ways you can reduce the dimension? Now, the question can also be, why do you first need to reduce the dimension? What does the dimension actually means about your data set? Why do you need to even reduce that? What happens if you don't reduce? Think about it. Okay, think about it. What happens if you don't reduce the dimension? There can also be a questions like, have you heard of the curse of dimensionality? What does that mean? That can also be a question. Get familiar with this, right? Let's see. The next question is says, yeah, various techniques that you should know about dimension reduction. Okay. One example I can give you, like PCA, if you have ever heard of, but PCA is not the only way to do that. There are a lot more techniques through which you can reduce the dimensions. So think about it. The next question, or the common question, very common question, could be regularization. What is regularization? What are the various types? Although I have given the types here, and of course I have hinted out what all you should learn about these types, like definition, formula, pros and cons, comparing between them. This topic is not just confined to classical ML models, but also very popular among deep learning concepts. So you must know about regularization. What does L1 regularization means, L2 and elastic net. So this can be one of the common favorable interview questions again. Let's see the next one. What is the concept of bagging and what is boosting? Again, if you are familiar with random forest working, you must be now clear about these words again. These are bagging is used in your random forest, and boosting algorithm is used inside your gradient boosting algorithm. Types of ensembles or ensembling techniques. Well, hint is given. There are two types. Now the question is, what are they? Well, so there are like two types. One is called stacking, and the other is called ensembling itself, right? So stacking is also there we have, and then voting, what do you say, ensembling method or through voting across, that can also be one of them. So you should know when to use which one, what it means. Okay, now the question here can also be, so what does random forest, which type of ensembling technique it has? Okay, random forest has, and what type of ensembling technique does gradient boosting algorithm or XGBoost has? That can be a question. Think about it. What is k-fold cross validation? That can also be a question. But I mean, or it can be a question like, why do we need to use k-fold cross validation? What does it do? What happens in it? How it solves problem? What type of problem it solves? So if you can relate an answer to all these possible questions, you are through. All right. Let's see the next question that you can expect further would be, what is the difference between univariate, bivariate, multivariate analysis? What do you do when you say you are doing an univariate analysis? That's what you are expected to answer. Taking an example is always good enough. So what does that mean? Again, there could be question like, are you familiar with upsampling and downsampling? How is upsampling different from downsampling? What exactly happens? So see, when these questions are asked, very rarely they expect you to know the mathematical formula behind it. But if you know the general concept, that's sufficient enough. So let's see the further questions. Yeah, again, very favorable questions that an interviewer can ask you, but not exactly in the same word, would be, are you familiar with precision recall, F1 score, confusion matrix? So I have seen most of the times the question do not come directly like, do you know precision, but rather it comes this way: how would you validate the performance of a classification model? So whenever question is in this form, indirectly the person is asking you, are you familiar with the matrices that should be used for classification model? Well, when we are talking about the matrices of the classification model, you can also add accuracy in the list. And the question can be, when to use accuracy and when to use F1 score, or when to use precision, when to use recall, when to use confusion matrix. So have you heard of imbalanced data set? If you have heard of, if you have worked with, then you know this answer thoroughly. If you haven't, go and Google when to use accuracy as a matrix and when to use F1 score as a matrix. What's the difference between precision and recall and confusion matrix? So if you can answer this thoroughly, or if you understand them thoroughly, you are already a pro. Let's go to the next question. That's activation functions. Yeah, so there are all many activation functions. Okay, but yeah, to the minimum, you must know about sigmoid and softmax and tanh. At least, if not their equation, then when to use which one? What does sigmoid does? What does softmax and tanh? So, and also if you can understand a lot more properties, like for example, softmax is to be used for multi-class classification problem. Okay, so in your logistic regression, whenever you have more than two classes in your target variable, softmax is used as your activation function. But when you have two classes, then it's better to go ahead with sigmoid. Although you can also make use of sigmoid in case of multi-class, but it will be more prone to noise then. So it's better to go with softmax because softmax is no better one. All right. Then, okay, how it stands is different from softmax. You can again read about it. Right. Then you can also go and learn little more detail about missing values imputation techniques. What is missing value imputation? Why do we have to do it? What happens if we don't do it? Um, what, how model will treat internally if we don't do this imputation? Do every models that we have does handles missing values? This could be a questions again. So various techniques to handle missing values you should know. Well, there's a huge list. I'm not going to discuss in this video, but I have already made a video on different techniques, different ways of handling missing values. If you are interested, you can watch it. I will leave it in the comment box. Right. Further, you should know about the coefficients of determination, or also called R square. And so what does R square do? What it indicates? I mean, of course, the name is called coefficient of determination. That can be a cross question in an interview because a lot of the people do not know that another name for R square is coefficient of determination. So be careful about it. And also, what does R square indicate? When to use R square? Okay. And in contrast, what is adjusted R square? What sort of problem is being solved by adjusted R square but not solved by R square? These are very interesting questions, okay? And please read about it. You'll like it a lot. There could be another question on, do you understand root mean square error, what it means? And of course, the formula for it, if you know the formula, because this is just a simple metric, and if you know the formula is very easy. So one is expected to know the formula. And what is the relation between MSE, variance, and bias? Well, there's a relationship between mean square error. MSE is mean square error, variance, and bias. So if you know the well, I think very few people know about this relationship. Even interviewer may not be aware until he somebody done PhD. So it's okay, but if you know, that will be an impressive point for you, and you'll get an edge over other candidates in the interview. So do know about it. And then what is EDA? That can also be a common question, may not be asked. Sometimes it's asked very directly, what is a EDA, but a lot of the time it's asked indirectly. So you have to understand, and don't worry, you are going to catch that question given that you understand what's an EDA is. So these are the few and very important DSAML concepts that one is always expected to know beyond knowing the machine learning algorithms. So if you know these concepts, you'll be able to answer a lot of the question. You'll be able to think critically, which is very much required, and you'll be able to think soundly. So please go back and read about these questions. I have made already videos on most of these topics. You can just see the list, and you can actually go about it. If you want video on any one specific or of these topics, let me know. I will try to make and share with you. I hope this video turned out useful to you. Till then, you have a happy learning, and I will meet you next with the next video in the sequence. Thank you.